Electromagnetic induction applications. In the magnetism chapter, we showed you the beginnings of an electric motor. Remember this guy over here? And asked you to look up what the plan for a real motor might look like. On the left is the picture we showed you, and on the right is a more realistic plan for a simple electric motor. Discuss with your group why this diagram is better, why this would be a better motor than this one. The plan on the left only let the wire loop go up, it would move up, and then when it got out of the magnetic field, the gravitational force would pull it back. It would certainly overshoot a little bit, and then it'd come back again. It would just kind of go back and forth. Not a whole lot of excitement there. Can't get a whole lot of work out of that. However, this diagram here, you've got the rotor, that's the piece right in the middle. This constantly rotates. So if that's constantly rotating, you can now drive wheels, pulleys, turntables, CD players, if you even know what that is anymore, vacuum cleaners, and any other device that could be attached. We're now going to discuss two applications of induction. One is the generator, which looks exactly like the motor on the previous page, but it is run backwards, and we'll talk about that next. And then a ground fault circuit interrupter. And you'll see these in bathrooms, near sinks in kitchens. It's a much safer way to deliver electricity to your appliances that run the risk of being hit by water or short circuiting. Compare the motor generator picture to the left here with the schematic drawing from Popular Science Monthly, volume 56 from 1899. Motors and generators have been around a long time. On the outside, we have a permanent magnet, and we call that the stator. It could also be an electromagnet, but the drawing here just shows a magnet, and this is just a regular permanent magnet. On the inside, we have a rotor. This is the thing that spins, and you can see here's the picture of it here, and there's wires going to it. Okay, now the current can either be coming into the rotor, in which case that would be a motor, because that current, and then using Faraday's law, would make this thing spin. Or what if we spun this with an external force, then the current would leave and we could use that current for something else, then we'd have a generator. Take a moment to review how a motor operates. Where was the current flowing? We've said that the current is flowing into these wires that surround the rotor, the coil here. So we have current flowing in an external magnetic field that will apply a force to these wires. And when this is engineered correctly, that force will spin the rotor. It'll spin this axle here, and whatever we have attached to that, like a vacuum cleaner or a record player, that will then rotate. We have made a motor. Let's work this in reverse. What if, instead of supplying current to the rotor, we spun this with some external force? What we would then have is the area of the rotor perpendicular to the applied magnetic field, again, from our permanent magnet outside here. That area would change. Thus, the magnetic flux would change, and by Faraday's law, a current would be induced in the wires. And we would pull that current off the wires and send it to various stations, to people for various electrical needs. So we would be generating electricity by spinning this rotor inside of this permanent magnetic field. The rotor over here can be spun by water hitting turbine blades attached to the rotor, or by wind hitting turbine blades, or by steam hitting the blades. And the steam can be generated by boiling water from burning fossil fuels or from the heat of a nuclear reactor. So now you can discuss, hopefully, what different types of energy are being transformed into electrical energy by the generator. Think about gravitational potential energy, thermal energy, kinetic energy, all being transformed into electrical energy by the generator.